Good morning.
Good morning, sir.
So we'll start. I think some more people are going to join. I was waiting for all the people. But now 4 of you are there. So we'll start. All are able to hear me, na?
Yes, sir. Yes, sir.
Yeah. So we'll start. Yeah. Okay. So we'll start with some basic revision of the structural model. And then we'll go to the moderation mediation part, which is the main part or course of today's FDP. So we'll start with the basic structural model. Those who were there in my previous class have already gone through it. So just I will revise it, not wasting much time on this. So this is a Marxist structural model that we are talking of. The second part of ACM, that is structural model. The first part of ACM is measurement model, which is the factor analysis part, or CFA, confirmatory factor analysis, where you get all the constructs as factors in your model and test out how good is the factor structure. You confirm the factor structure. So after you have done that, you go straight towards the structural model, where you actually test the dependent-independent relationships. So in that, we have discussed this example. Those who are there, we already know this example. But again, we'll revise it once more before proceeding into moderation and mediation. So this is the structural model that we have discussed last time. This is how the structural model looks like, where we have 4 independent variables, ER, IS, SC, and S, and 2 dependent variables, CS and CL, which are customer satisfaction and loyalty. And ER is technology usage reliability, and technology security is IS, and staff competence is SC, and S is customer service. So once we have that, then all these ER, IS, SC, and S all are independent variables, and CS is one dependent variable. And then ER, IS, SCS, and CS all are independent variables for the dependent variable CL. So in terms of regression, there are 2 regressions which are simultaneously being run in this structural model. That's what is the advantage of ACM and structural model. Instead of running multiple regressions for multiple dependent-independent relationships, you can run a structural model in ACM, which will test the multiple dependent-independent relationships together. So once you have that model in place, then you go to the data set, which is this button, and select the data set, that is this one. And once this data set is selected, this number will show, and we'll click on it. And then we go to this output analysis properties, where you go to output and select this 1, 2, 3, 4 on the left hand side, 1, 2, 3, and the last button, 4 in the left hand side, 4 in the right hand side. In this case, it is 1, 2, 3, and 8. In the right hand side, it is 1, 3, 4, and 6. This has to be selected. Once you have selected that, see, the output is disabled. Once you run the analysis, then only the output will be enabled. So once you have selected that, click on this run button and it will run. So once it has run, the output or the text output where you can show the results is seen. So once you have that, we'll go to the output directly. This is the output screen where you go for looking at the estimates of the paths, which one was significant out of the total 9 paths which we are talking of. So in that case, you can see The path from SC to CS is significant. The path from ER to CS is significant. The P values we are looking at. Then path from IS to CS is significant. But however, the path from S to CS is not significant. And then again, coming to the rest, the ER to CL is not significant. IS to CL is not significant. SC to CL is not significant. However, S to CL and CS to CL are significant. So out of the total 9 paths which were there in the diagram, only 1, 2, 3, 4, 5 were significant. Rest were not significant. So this is what is the hypothesis testing part of the structural model. And just like in CFA and all those or model, you need to look at the model fit indices, where you look at this C mean by degrees of freedom or the chi square by degrees of freedom, as well as RMR, GFI, GFI, PGFI, NFI, RFI, IFI, TLI, and RMSCA. The lower the value of RMSMA, below 0.1 is acceptable. And same goes for RMR. Lower the value, it is better. Below 0.1 is acceptable. But if it is to be good, it should be around 0.0506, which are not. And for the chi-square by degrees of freedom, it should be below 4 is acceptable. Below around 2, 3 is very good. For GFI, AGFI, NFI, RFI, all this, it should be above 0.9. 0.9 now above is very acceptable. And the rest is very good. So that's what we need to report, the model fit indices. And also, if the model fit is not good, as indicated in the last class, we look at this modification indices, where we look at these high values and try to correlate those errors so that the model fit indices improve. For example, in this case, it is E22 and E23, which is quite high, and E18 and 2023 is high. And then E18, 19. And E8, E9. 8, 9, 18, 19, 22, 23, and 18, 23. So if we go back to the diagram and if we try to correlate those error terms, E8 and E9 you correlate, E18, E19 you correlate, then E18 and E23 and E22, 23. E22, 23, it is yes. E18, 23. These are the high values in the modification indices, which should be correlated with each other. So once you correlate them, you run the analysis again and go to the output again. Yes. Let me go to the output again. Yeah, and now you can see the model fit has improved quite a bit. Chi-square by degrees of freedom has improved. So is GFI, AGFI, and NFI, RFI, all of them has improved, as well as RMSCA. So in this way, you go on doing a trial and error method till you get the model fit indices all in the good and acceptable zone. And that's the last model fit that you need to report. So model fit is one thing you need to report, as well as the estimates where you talk about the hypothesized paths, where you see which of the 9 hypotheses that you have talked about or 9 paths are significant, which is in this case 5 out of 9. This is significant, this is significant, this is significant, this is significant. And now you can see, once we have done that modification indices, out of previously it was 5 only, but now you can see 1, 2, 3, 4, 5 and 6 has become significant, which was not there initially. Initially it was only 5. Now 6 has become significant out of 9. So this has impacted the hypothesized path also. So in this way, we report the structural model. So this was basically the revision of the structural model. Any questions or any doubts on this before we move into the moderation and mediation part? Any doubts, any questions, anything?
No, sir.
Fine. So then if there are no doubts, we will move towards moderation and mediation. Yeah. So tell me, what is your idea of moderation and mediation? What do you understand by these two terms, moderation and mediation?
Mediation is something which explains the relationship between the strength of the relationship between independent and the dependent constructs.
Okay. Yes. And okay. I'll tell you, mediation or mediating variable is one in which basically you try to see whether there is a variable in between two variables, which is also impacting the relationship between the two variables. The example that we looked about in the structural model, is there any mediation possible in that?
The previous structural models are just now which
Yes.
yes, I think we can introduce a mediating construct.
So was there already a mediation in this case?
I was I think I was doing something else at that time. I didn't notice properly.
I'll go back to it once more. I'll go back to it once more. Is there a mediation or mediating relationship which you can see here?
Yes, Professor.
Yeah, it is there.
What can be a mediator here? Which one?
CS, customer satisfaction.
Yes, exactly.
Yes.
So any of these ERIS or CNS you take, there is a direct relationship between them and CL, and then there is a mediating relationship between ERIS or SCNS through CS to CL. So that's what it is, a mediator. A mediator is something like one variable is one which specifies how or by which mechanism given effect is occurring between an independent and a dependent variable.
Yeah, sir. Can we look at the conceptual framework of this model, sir?
Which one?
A conceptual framework of this structural model. Prior to this, there would be one conceptual framework. So if you have it with you, can we
The
have a
CFA
look?
model you were saying?
Not CFA model, sir. Not the measurement model also.
Okay. The conceptual
a conceptual framework. Sir.
The conceptual framework I'm telling you, na, ERIS, SC and S all are affecting CS and they are all affecting CL also. and they are affecting CL through CS. So CS is the mediator in this case.
Okay, sir.
If you remove all those circles and all those things, you will get it. You realize what is happening.
Yeah, okay, sir.
So CS is a mediator. So basically mediating variable is one which specifies how or which mechanism a given effect is occurring between a independent and a dependent variable. So mediator address how or why X causes Y. That's what is mediator doing. While what is moderation then?
In the presence of a third variable, how the relationship will vary?
Yes. There is a third variable which is there in mediation also, but mediator is a variable which is directly impacting the relationship in between. So there is an X which is causing Y, but there is an X which causes an M, and M also causes Y. But in this case of moderation, it is a third variable which affects the relationship between the dependent and independent variable, but it is not having an effect of X on the moderator. The moderator affects directly the variable. So nature of the impact of the predictor on the criterion variable varies according to the level or the value or the moderator. So the basic difference is what? Mediators address how or why X causes Y, and moderator address when and for whom X causes Y. When and for whom X causes Y. So I'll take two examples. Let's say we have a categorical variable. For example, let's say the advertising frequency of a particular food item, let's say something like as a paneer or ice cream or something, impact sales. But the taste palettes are different for North Indians and South Indians. And we take another continuous variable. For example, the ad frequency of same thing, let's say ad frequency of a mobile company, let's say Samsung or something, impacts the attitude towards the brand. But also it depends upon smartphone literacy or knowledge. So that is the case. Which is a mediated case, which is a moderator case.
Professor, can you please repeat? Sorry, I couldn't get
Let's
it.
say advertising frequency of ice cream impacts sales, and the taste palettes are different from North Indian and South Indians. And then there is Samsung company gives advertisements for its mobile phones, which impacts the attitude towards brand. But it depends on the perception and knowledge of smartphone.
First one looks like mediating example. The
Okay.
second one, moderator. It is moderating. The third variable is moderating here.
I'll give you the example once more. Ice cream advertising frequency impacts sales, but the taste are different for North Indian versus South Indian.
Yeah, this one is moderation.
Yes, because it's a categorical variable. The advertising frequency of ice cream or paneer impacts sales. These are continuous variables, but the taste palettes are different for North Indian or South Indians. So categorical variable. While the second one, Samsung frequency of Samsung ads impact the attitude towards brand, but it is impacted or it depends on the knowledge and perception of the smartphones, which is continuous variable impacting the relationship between the ad of Samsung versus attitude towards brand. So this is a moderation. So basically mediator. So basically you are talking of a continuous variable, which is a third variable. It is a mediator, while if it is a categorical variable, it is a moderator. That's the basic difference between a moderator and a mediator. As I said previously also, so basically mediators address how or why X causes Y, while moderators address when and for whom X causes Y. That's the basic difference. So something like intensity of a disease impacting the evaluation of threat, impacting the frequency of self-medication. That is what is a mediating relationship. Or let's say there are smokers, the type of cigarette impacting the age, impacting the cancer mortality rate. These type of things are your mediating variables. While if you are talking of moderators, they are variables which are relatively immune to change over time, like a personality trait or a gender or ethnic group or something like. While mediator tend to be variables that change in relation to other variables, like anxiety, helpfulness, honesty, etc., mood, etc. So that is the basic difference between the mediation and moderation. So we'll go directly now towards the examples and how to do it. So let us go to mediation first. The famous approach of doing mediation is known as the Bannon and Kenny approach, which looks like this. So there are certain conditions it should be met when you are talking of mediation. So first is the path A. The independent variable should affect the mediator. That is the path A. Second is mediator should affect the outcome variable, which is Y. Outcome variable is Y. Independent variable is X, and mediator we control X, M, and Y. In this way, we should look at it. So, second is the path B.
So we are not able to
Yes.
see the screen, sir. Can you please share the screen?
Okay. I have shared it. Why it is not showing? Share it again. Can you see it now?
Yes, sir. Yes, sir. Now we are seeing.
I don't know why it was not showing. So what was I saying? This is the famous Bannon and Kenny approach of testing mediation. So first is the path A, where the independent variable or is the X variable impacts the mediator. The path A should be significant. Second is the variations in the mediator affect the dependent variable, that is path B. That is the M should significantly affect Y or outcome variable. And when both A and B are controlled, then there should be a relationship between the X and Y, independent and outcome variable, independent variable. So mediation is of, there can be three types or three situations in this case. One is the situation when A and B are both significant, and then C is also significant. That means the mediator, the independent variable, is also impacting directly the dependent variable, as well as it is affecting the dependent variable through the mediator also. So all A, B, and C are significant. So in this case, you can say that this is a case of partial mediation. The direct effect is also there, and the mediative effect is also there. And then comes the second situation when A and B are significant, but C is completely zero. That means C is not significant. That means the independent variable is affecting the outcome variable through mediator, that is complete or full mediation. And third is the situation where C is significant, but either of A or B is not significant. That means the direct path is significant, but not the mediating path. This is a situation of what we call as no mediation. There is no mediating effect. All three situations can come. So there is a way of testing it. We test this mediation. How we will see through SEM when you run that analysis. but there are a series of equations which you use. So we'll go to that, but before going to that, there is a critique of this approach. There was a critique of this approach. So they said that as per their knowledge, the direct path should not be checked. It should be, as per this approach, Jhao et al., they say that direct path should not be checked. Instead, we should check only the mediating path. So there is no need to be an effect to be mediated. There is an indirect effect that you need to check for that. You should not go into all those complications and accordingly decide whether there is a mediation, non-mediation, etc. and all those things. This is an example that I have given of mediation. A star cast is something of a movie which can impact the box office collection. But if people are able to identify the role which the star is playing better, that can also impact the box office collection. So role identification is the mediator. Star cast is the independent variable or X. Box office collection is a dependent variable or Y. So how do you look at or test for this mediation effect? So this is the diagram we are talking of. We run a series of equations, a number of regression equations. In fact, 3 equations which helps us to test that. These are the 3 equations. So first one is where X is the independent variable and M is the dependent variable or outcome variable. So we run equation as the mediator as the Y and independent variable as X and test whether it is significant or not, the path A. Second is the direct effect with Y as the Y outcome variable and X is the independent variable, which is the direct effect. Third is the equation where you take both the mediator and the independent variable affecting outcome variable or Y. So Y, we have looked at CX and BM. So what happens? First thing is that the independent variable should affect the mediator. Second, there is an effect of the Y independent variable on the outcome variable. And third, we check for whether both of them together affect the outcome variable. So if we have A as significant as well as Y as significant, all the 3 are significant, then what is the case? Full mediation, no mediation, partial mediation?
Partial mediation.
Yes, then it is partial mediation. Now, if we have the first one significant, second one is not significant, and third one only M is significant, that is B is significant, then what is it? In the first case, A is significant, the first equation. Second one, the equation, it is not significant, that is C dash. And in the third equation, only B is significant.
It's full mediation.
It's full mediation. There is no partial on the, because the direct path is not significant. And then if you have no mediation, then what will happen? Your second one will be significant and first one may or may not be significant, but in the third equation, the B part will not be significant. That means no mediation. So there is a further test of mediation which is done, which is known as Sobel's test. So this is a formula where we Z test or Z. When we run the equation and through SEM, we'll tell you or we'll show you how to calculate this, and this is known as Sobel's test. So if Sobel test is significant, then there is a mediation effect which is there. That is important to test in the Barron and Kenny approach, which is the most used, most common, and the most, you can say, a very easy way to look at mediation without any complications. So let us go to the situation first. I have sent you a data file. Yeah, just one second. There is a mediation data file I have sent you. This is the mediation data file. And then there are three constructs basically. One is security, another is usefulness, another is your information integrity. These three constructs are there. One is having two of them, security and usefulness, have three variables under it, and information integrity construct has 4 variables under it. So this is the data file I have sent you. How to run the equations directly, we'll go to the path. The first equation that we talked about, that is M is the outcome or independent variable, and the X is the independent variable. So in this case, security is your X and information integrity or II is your M. The first equation that we have talked about in the series of equations. So in this case, you can see we have run a model. In this case, you go to the data file. Select the data file. Once it shows the numbers in N, you click on OK. Go to the output and select those things which you need to select. The same things 1, 2, 3, and 8 on the left hand side, and 1, 3, 4, and 6 on the right hand side. Once you have that in place, you run the analysis. So once you run the analysis, the output comes. Go to the text output. Can you see the text output?
Yes, Professor.
Yeah. So once you look at the text output, you need to look at the estimates. The path between security and information integrity. Is it significant? The p-value you look at. Security and to information integrity. That's what the model was showing. The path from this. So as per this output, is it significant or not?
Yes, Professor.
It is significant, but p-value is showing 0.000 and below. And the estimate is 0.393. You need to remember this because that will be later used for the Sobel's test. So once you have this in place, then you go to the next one, that is the second equation. That is the direct path from security to usefulness or utility, whatever way you tell it. Now, in the same way, you need to select the data file. Once you have selected the data file, you need to go to the output and then you run the analysis. So once you have that, you go to the output. So is the direct path significant? Look at the p-value. The second equation we are talking of. The direct path is also significant or not? Yes, it is significant because p-value is less than 0.000. The estimate, you remember, 0.473. So after you have done these two, the first equations, that is, you are talking of this equation and this equation. Now you look at the third equation. So the third equation will be like this. The same way you select your data file, look at the output properties and run the analysis and go to the output. Are both of them significant? Both B and the direct path? Security to information integrity and security to utility or usefulness. Are both of them significant? Both C and M, C and B. Are both of them significant or not?
Yes, Professor.
Yes. So all three paths are significant, or all three regression equation, everything is significant. Now, a very important part of this thing is, as I told you to remember the values. When you directly looked at between the relationship between the X and M, it was significant, which is this value, 0.393, and it was significant. Then the direct path was also significant, 0.473, but the value is 0.473. Now, when we are running both the mediator as well as the what do you call as the independent variable in the third equation, both are significant, but the value of the direct path has come down from 0.473 to 0.184. So if the mediation is there, and if the direct path is also significant, when you run the equation with the mediator and the X variable as independent variables and check it effects on Y, the direct path regression coefficient should come down. And that's exactly has happened. From 0.473, the effect, when you are running the mediation effect, checking for the mediation effect, it is coming down to 0.184. So the mediation is there because all the paths are significant, both A, B, and simultaneously B and C together are significant. And also the direct path regression coefficient, when you are testing only for the direct path and compared to the equation where both of them are tested together, the direct path regression coefficient is coming down. The effect is coming down because there is a mediator effect. It is through a mediator that is happening. So if that is the case, which type of mediation is this? Can you tell me? What is the mediation type of mediation we are talking of?
Partial mediation.
It is a partial mediation because the direct path is also significant independently, and when you are talking with mediator, the effect is coming down, but it is still significant. So this is an ideal case of partial mediation. If it was not a partial mediation and if there was no mediation effect, then the first equation or this thing would not have been significant. Even it was significant, even if this path was significant, that is x to m. But in the third equation, when you are talking of the b part, that is m to y, it is not significant, then it would have been a case of no mediation. So either the direct path is significant, that means this path is significant, this is significant, SEC affecting utility, the direct path is significant, and either of this to this, or and the m to y, that means II to utility should have been non-significant. That means there is no mediator effect and there is no mediation. And if the full mediation was there, then in that case, the first would have been significant, this would have been significant, but the direct path would have been non-significant. And in the case of the third equation, the mediating path should have been significant, but not the direct path. So that is when it had been a full mediation. Any doubts here?
Professor, one doubt is like when we are running separately, like here in this particular model which we are sharing now, it is a mediation model.
Yes.
Suppose if we are running separately, only dependent and independent, and then that should be significant, right?
The second equation you are saying, this one.
Path C, yes, when it is run separately, that should be significant.
If it is significant also, but in the case of the third equation, the path becomes non-significant, then also it is a full mediation.
Yes, Professor, got it.
So full mediation can happen in both cases. That is, the direct path is significant, but when we are running both of them together, the direct path becomes non-significant. That is also a full mediation. And also in some cases, you will find that if you are running independently, only the dependent independent together, the direct path is also not significant. And in the third equation, also the path is not significant. In both ways, it is a full mediation that we are talking of, in both the cases.
Okay, so when it is run separately also, it may not be significant.
It may or may not be significant.
Okay.
Irrespective of whether the direct path, when it is run separately, it is significant or not. If you come to this equation, third equation, and your direct path becomes non-significant, then also it's a full mediation.
Yes, Professor. That third portion I was able to understand. My doubt was if it usually what I understood earlier was the direct path is run separately, it should be significant only in the
It may or may not be.
Okay. May not be. Okay.
It can be. It is possible that it is significant. It is possible it is not significant.
Okay, Professor.
So if it is very highly full mediation is there, direct path will not come significant independently also or in this equation also. But a slight effect is there. In that case, what will happen? The direct path may come significant, but when you run it in the mediator, in the third equation here, it will become non-significant. So irrespective of whether the second equation is significant or not, or the direct path, if it becomes non-significant in the third equation, then it becomes clear.
You can carry on. We'll go.
That's what the same results I have given here. The first equation was this, second equation was this, third equation was this. The original equations, and in our example how it has come out. So this was significant. This was also significant. And in this case, both were significantly affecting this. But you can see the value of the direct path has come down in 0.47 to 0.18. So in case of no mediation, this will not be effect. This will not be significant. This path from II to utility, this will not be significant if it is no mediation effect. If there is a full mediation effect, that means this direct path from SEC to utility, security to utility will not be significant, irrespective of whether it is significant in the second equation. In the third equation, if it is not significant, then there is a full mediation which is happening. And the partial mediation is our case, where this path is significant, direct path is significant, and in this case, both the paths are significant, but you can see the value of the direct path has come down from 0.47 to 0.18 because there is a mediator which is present. Clear? Any doubt till now? Any doubt on any of them? Okay, so if there is no doubt, we'll go to the next one. How to report these results. First is this. This is to be reported, all the three equations, they are significant, non-significant, and depending on the significant, non-significance, you have to go to identify the type of mediation, whether it is a partial mediation that we are talking of, whether it's a full mediation we are talking of, whether it is a part. A very important part of along with this, as we have talked about before, is this Sobel's test. This has to be significant if the mediation effect is there. This is important part of this. Now, how to do this Sobel's test? Oh, excuse me. Oh, excuse me. The path A and path B, the regression coefficient values, which we have got from the table 0.391 and 0.744. And the standard error in relation to them are 0.058 and 0.106. So we get B into A, which is the numerator, and in the denominator, what do we have? B square into S square plus A square into SB square, square root of that. And that's exactly we have calculated here. S square is B square and A square. So B square into S square plus A square into SB, B square, SB square into A square. Square root of that is your denominator. Once you have this divided by this, you get the Z value, which is highly significant. So if the mediation is there, the Sobel's test confirms that mediation if it is significant. If the mediation is there, this is confirmed through this Sobel's test. And this has to be also reported when you are reporting the mediation results. So what do you report? You report first of all the significance or non-significance of all the three regression estimates for the three regressions that you have run. The result of Sobel's test, if it is it should be significant. If it is not significant, the mediation effect is not there. So this should be significant. And then looking at the equations, the three equations, you have to decide on whether there is a mediation, whether it is a full mediation, whether it is a partial mediation, or whether it is a no mediation case. In our case, it was a partial mediation because the direct path as well as the mediated path both were significant. And the direct path, when we are talking of the mediator, is reduced in the equation. The value is coming down, the coefficient value is coming down. So it's a partial mediation. If the direct path was not significant in the third equation, then it should be a case of full mediation. And if the direct path is only significant in the third equation and the mediation is not significant, then it is a case of no mediation. Any doubts on any of the cases of what is mediation, how do you run it, what do you look at, and what are the results to be reported? Anything on any of these stages?
Sir, in Sobel's test, the result value is 4.8620, sir. So how you are saying it's highly significant? Is there any range of values?
This chart, it is significant.
Okay, sir. Is there any range for this value? This is it value?
Yes. Generally, if it is above 2, generally it will be highly significant. Look at the Z value, na? Z value chart is there, na? There you will find whether it is significant or not. This value is highly significant. Look at the Z value chart, you will find out.
Okay, sir.
Generally, if you have the value above 2, it will be significant. It is talking of a normal distribution, na? If it is above plus minus 1.96, it is highly significant, na?
So
Okay,
here, sorry to disturb, Professor, we will be taking Z value, comparing with the table and say whether it is significant or not, right?
The Z value itself, whether from the Z chart, you will find out from the value itself whether it is significant or not.
Okay. So no, here we won't be having P value, we will go to Z value.
The Z value directly will show you in the Z value chart.
Okay.
Calculate the Z value using the formula, that is this formula. This one, B and A are the regression coefficients for path A and path B, and SA and SB are the standard errors. So B, A, and where do you get it? You get it in this data. This is B and A, 391 and 7.44, and these are the standard error SA and SB, 0.058 and 0.106. So using that formula, now I've calculated the Z value, and after you get the Z value, looking from the Z value chart, you can see from this value, you can cross check and verify from the Z value chart. This is a highly significant value. So Sobel's test should be significant when you are reporting the mediation results. You have to report the Sobel's test also. It should be significant because if it is not significant, mediation effect is not there. So if the mediation effect is checked from the three equations and then you report the results of Sobel's test is significant, that means your mediation is confirmed. And then looking at the different equations and their variables and their significance, you decide whether it is a case of full mediation, partial mediation, or no mediation case. So in case of no mediation, the Sobel's test also will fail. It will not come, it will come as non-significant if the issue is of no non-significance.
No, Professor, here we are taking the regression weights, are not the standard regression weights, right?
Yeah. For the calculation of Sobel's test, you are saying?
Yes, Professor.
Yes. You can, because the standard error will not come in the standardized regression weight, na?
Okay, sorry, yeah, got it.
So it will not come. It is a normalized value, na? Standardized regression weights are normalized or standardized values. So you will not get the standard errors. Okay.
Yes, Professor.
Yeah. So any doubt on mediation before we go into the moderation part?
So for example, if you have two mediation in a single model, you should like see it for separately, sir, for each mediator.
You can see it separately or you can run it together also.
If we run it together, it will be the same result or it will be a different result, sir, compared to the...
It will be the same results will come out. If you do it separately or if you run it together, results will not much differ.
Okay, sir. Thank you, sir.
The type of mediation will not change. So if it's a partial mediation or field mediation or no mediation case, if you have two mediators in your model, if you run it separately, you can run it both ways. You can run it separately, you can run it together also. So if there is, let's say a case is that one is having full mediation, the other mediator is showing partial mediation. So if you run it separately also, it will show the same results. And if you run it together also, it will show the same results. Only thing that the values of those regression coefficients or standard errors may differ slightly of 0.001, 0.002. That minute difference may be there, but the nature of the mediation will not change.
Okay, thank you, sir.
The basic nature of the mediation will be same. Okay. Yeah. Any other doubt? Anybody else?
Professor, can you just tell us how the equation changes if it is a parallel mediation and serial mediation?
If it is a partial or what?
Sorry, parallel and serial mediation.
Parallel is basically, no, you are saying parallel and severe mediation. Severe is full mediation, no? Only.
Parallel, serial, sequential mediation.
Okay, you are saying serial mediation.
Yes, Professor.
Serial mediation means you are saying two mediators are there together.
Yes, two mediators. One will be the mediator for another mediator.
Equation will not change, no? It will be, see, it will be happening that M1 and M2 is there, no?
Yes, Professor.
So M1 and M2 is there. Then it will, okay, if it is a parallel, let us take parallel first. That means one mediator is not the mediator for others. Two mediators are there.
Yes.
2, 3 mediators are there, parallel mediators. They are all mediating the effect between X and Y. In that case, the equation remains the same. The equation, the three equations, it remains the same. Clear?
Yes, Professor.
Yeah. In case of serial mediation, what happens is that you take the M1 and M2 is there. Let's say two are there, M1 and M2. So you take M2 as Y and M1 as M and X will remain same. And then the series of three equations will come in. Clear?
Yes, Professor.
And in the second one, the M2 case, what will happen is M1 becomes an X, M2 become M, and Y becomes Y.
Yes, Professor.
And then you will use the same series of three equations.
Okay, Professor. Got it.
Clear? Any other doubt? Anything related to mediation before we put into or go into moderation? Anything you want to ask? So what is the difference between the mediator and moderator? As I said, mediator is a variable which will be different between X and Y. That means it addresses how or why X causes Y. While in case of moderator, it is a variable which affects the relationship between X and Y. So basically it addresses when or for whom X causes Y. So moderation is something like this. It moderates the form or strength of relationship between a dependent and an independent variable. Now, moderation is also checked through normal regression. There is a way of checking moderation through normal regression, where you do, what do you do? You have a moderator variable, you put it, you may create a new variable by multiplying the x and the moderator variable, which is known as the interaction variable, and check for the interaction effect, whether it is significantly affecting or y or not. But that creates some problems and the results may not come out separately, and that's why there is a second method of doing moderator, which is through SEM, which is using the subgroup or multi-group analysis in SEM instead of doing it through regression. In fact, the regression method that you are talking of, like putting an interaction term as another x variable in the equation, can also be done through SEM also, but that is not a very robust way of testing moderation. A multi-group analysis or subgroup analysis using SEM is what we are talking of. Used are much more robust method of testing the moderator effect. So moderators are generally categorical variables like gender, like age groups, or some groups which are low and high, something like that. So basically, what do? You try to compare from the SEM perspective. Multi-group model is something like the model is same, but you are testing whether the model affect behaves differently for the two groups or two samples, whether it is behaving differently or not. So basically, we call it a multi-sample conformity analysis is another way of looking at it. So there is a chi-square test which is performed when you run the moderator variable or moderation, which is an empirical way of assessing whether the groups or the two groups that you are talking of or which you are using as moderator is different or not. So if it is not significant, that means the chi-square test, I will show you once in on the analysis, I will show you how and what to do in the chi-square test. If it is a chi-square test is significant, then there is a moderating effect that the model will behave differently, or the relationship between x and y will be different for the two groups that you are talking of. If it is not significant, that means the relationship between x and y is same for the two groups. They do not vary between the groups. That's what you generally look at and moderator. So I have shown you, sent you a moderator variable data set also. So I'll show you that. Just one second. The moderator data set I have. Yes. So this is the data set that I have shared with you. So it has number of variables we have, but what is relevant to us are these variables only, which we'll be using. This is the moderating variable gender, which has been coded as 0 and 1. And these are the variables that we are looking at. So org, CUST, SEC, II, and TF are all your X variables, and your usefulness or USEF is your Y variable. So we'll look at the moderating effect of gender on multiple X's together. Not one X at a time, but multiple X's together will test how the gender as a moderating variable is affecting or not. So you go through this data clearly, what is there, and also go through or look at mediation if there is any doubt, and just let me know. So I will be taking a break and we'll meet around after 20 minutes. Any doubt at this moment? At any of these things?
No, Professor.
Yeah. So if there is any doubt, just let me know. Once we have the break, go through it. Just look at the concepts that we have talked about. Also, any doubt on the data of the moderation or mediation or anything, you let me know once we come back from the break. Okay. So there was some network issue from my side, so that's why I was not able to join. Now I think everybody else has joined. Everybody is okay. You can hear me. Yes.
Good afternoon, sir. This is Tarin Moy from Gitam University.
Hello.
Sorry for joining late. I tried because to join at around 11:30. Then Umagan sir told that you were having some issues with the laptop. I joined up.
No, fine. No problem. Now you have joined, na? Fine.
I had invigilation duties, so
you have mailed me. I remember that.
So that's why I dropped you a mail.
Yeah, answer.
Thank you for your appreciation.
Just 1 second. ये वाला नहीं चल रहा है। अभी तो चल रहा है, चल नहीं रहा था वो भी। So all of you? Yeah. Hello?
Yes, Professor.
Yes. Okay. So we'll start with the next part of moderation as we are talking of. So how to do the moderation part. So in moderation, the way of doing it in SEM is multi-group analysis. It's called a multi-group analysis using SEM. Basically what do you do is we do run a regression for the paths, and then we try to find out among all the paths, which were in our case there are 5 x's and 1 y. So in that our moderation variable is gender. So which of the paths are significant? So this is our example that we have taken. Those variables are there in your data points. So we are testing this model with gender as a moderator. And what do you do? I will tell you. I'll go back. I'll go to the moderation part. In the first stage, we run the regression model like this, the same one. So once we run the regression model, and how to run it, I will tell you. Then we check which of these 5 paths are significant. In this case, 5 x's are there. Which one is significant? To run it, you have to put the data file. Only thing is that in this case, you have to put the data file into 2 parts. As you can see, the same data file I have taken in 2 parts by dividing into 2 groups. This is why it is called a multi-group analysis. So the moderator variable has divided into 2 groups using the moderator variable. So what I have done is that I have selected the file, and then what I have done is selecting the two groups, one group, we look at this grouping variable as gender, then put a group value where female has been coded as 0, select that and click on OK. And similarly for the second one, again you go to the grouping variable, select gender and go to the group value and select 1. So now you can see your total data is divided into two groups, which is the moderating variable, gender in this case. So all the results will come for the same model in two groups. Whether the two groups are different or not, that's what we will check. So once you have that data file in place, go to the output. Same things you need to select, nothing else. 1, 2, 3, and 8, and in this case 1, 3, 4, and 6 on the left and right hand side, and run the analysis. So once you have run the analysis, go to the output. Now there are two things. One is you need to look at the paths. Now you can see the results are shown here for all the 5 paths, for female group and for male group, the two groups, the moderating variable. The same model, it has been checked for two groups separately. Now if we look at the female one, you can see out of 5, 2 only are significant. These 3 are not significant. Now in case of male, 3 are significant, these 2 are not significant. So what exactly I have told? That you need to retain those paths which is significant for at least one group, and then remove one insignificant path at a time. So in this case, if you look at the results, there are 2 which are not significant for both. That is customization and security, which is not significant for both female group as well for male group. While this is TF is significant for male group, but not significant for female. So if it is significant for one group, you should not remove it. Only the ones which are not significant for both should be removed. So looking at that, you need to remove, see if which is highly non-significant, customization for female, and similarly customization for male. So you remove that from the model. So what do? You go to the model and just remove that path and run the model again. And again check and see if there is not significant. Again, the second one you do. In the similar way, you run it 2 times. So once you have done that, you stop when all the paths are significant for both the groups. You go on removing till you get all the paths significant in your groups. So what we have done, I have skipped the stages of removal one by one. I am showing you where we have stopped. So if you run this same model, having the same data file and same analysis properties and all those, when you run it, here in this case, after you have removed one by one both of them, you can see for female, 2 are significant, 1 is not. For male, all 3 are significant. So it is at least for one group, all are significant. So we'll stop here. And this is the model that we have. So once you have that, after removing all the models, the next step is checking for the chi-square difference between these 2 different models. And how do you do that? What is the chi-square you get? The first chi-square that you have got is this. Yeah. It's not coming. Yeah, 1 second. It's not. Yeah, sorry. Now the chi-square that we have got for this is this. For the model where we have stopped. We have stopped removing after seeing all 3 are significant for at least one group. We have stopped here. So you need to note down this chi-square, which is 5.54, and the degrees of freedom is 4. Now what do you do? Next stage. So we need to run two models. One is this original model that we have run, unconstant model, and second model is we constant the regression weights across the groups, and the chi-square difference versus the degrees of freedom has to be checked and see if it is significant. Then only we can say there is a moderation effect. So what are the two models that we are talking of? These are the two models. One, this original model that we have after removing the non-significant paths, and then we constant them like this. Now, how do you constant them? I'll show you. Just put a constant on each of the paths by going to that path, go to object properties and go to parameters, put this constant. So once you have done that, you run this model also. So once you have run this model, go to the model and check the chi-square and degrees of freedom for this 13.652 and 7 for the constant model. Okay. So once you have a constant model, what is the thing? You can see the estimates for the original model when you are looking at the outputs for the original model. These estimates were different when you look at the female group, these regression coefficient estimates, and the male group. These were different. But in the constant model, these estimates are same for the male group and for the female group. So once you have this chi-square of both the constant and unconstant model, then you go for this chi-square test. So this is the fully constant model with chi-square and degrees of freedom. This is the unconstant model, chi-square and degrees of freedom. So once you have that, this is the difference of chi-square, this is the difference of freedom, and you check for the chi-square test for difference of chi-square by difference of degrees of freedom, whether it is significant or not. So from the p-value, it is significant, and since it is significant, we can say that the moderation effect is there. That means the females and males behave differently for this model. That is what the moderation effect, or that's how you check for moderation. The females and males differ or behave differently for the model. So moderation effect is significantly present in the model. The females and males behave differently, or the model behaves differently for the males and females, because this chi-square test is significant. So once you have that in place, what is the next place? Next step? Then you need to look for each of these paths. For each path, whether the moderation effect is there. How many paths are significant? 3 paths. Out of the 5 paths, 2 paths have been removed, and we checked for 3 paths. As per our test, when you compare the two constant and unconstant model, the difference of chi-square by difference of degrees of freedom is more than the is significant, and that means moderation effect is there. That means for these two groups, males and females, they behave differently for this model. Now we know the two groups behave differently for the model, but we don't know for all the 3 paths they behave differently or not. Since we do not know that, then we need to check for each of these paths. So once we check for the path, how do we check for each of these paths? We put a constant for each of the path one by one and check for the same chi-square difference by degrees of freedom difference for each of the paths, using one path at a time. That's how you do it. And I will show you how I have done it. Yes. So I have taken the first path. Okay, before we proceed into this, till now what I have said is clear? Any doubts here?
So how to put the constant model? So what is the procedure? I can't understand.
Yes. Go to this particular path. Go to object properties and in the parameters put this regression weight. Just type it.
Type as W, so or
Yes,
W1.
whatever you want to put. Don't type E. Anything else is okay because E it will take as an error.
Oh, okay.
So generally we
Okay,
put W. That is best.
Okay, sir.
Yeah. And just put it like this. It will come for the same. This model also, when we have talked about the constant model, we have put the W for all the three. Now, after putting that, we check for the chi-square difference versus degrees of freedom difference from the constant and unconstant model. And if the chi-square test comes significant, that means moderation effect is there. But we cannot say whether the moderation effect is there for all the three paths or not. That's why we need to check for all the three paths separately. And how to do that? Put a constant of one path at a time. So we have put constant from org to use F. That is how we put the constant. That is from organization information to customization. We have put this constant and run the model. And look at the output. Now, what is the chi-square? 11.843. And the degrees of freedom is 5. Fine. That's what I have told you. That's what you have to check for the chi-square difference versus degrees of freedom difference. One path at a time. So 11.843 and 5. And the original unconstant model was 5.54 and 4. And this is for this path 11.843 and 5. Similarly, look at the chi-square difference versus degrees of freedom difference, and the p-value comes significant. That means this path is significant. So moderation effect is present in this path. That is from organization information to usefulness. This path is significant. Clear? Any doubt here?
Sir, I have a doubt, sir.
Yeah, tell me.
In the Excel sheet, there is values in the last column. What are the values? This last column. So what is the values?
This is just this C5 by D5. This is chi-square difference versus degrees of freedom difference.
Divided by degrees of freedom.
This is the chi-square value that we are checking for with the p-value.
Okay, that's in the output, right, sir?
Yes.
Okay.
This is the p-value, na?
Yes, sir.
The output we have got this for the unconstant model and for the path constant here. So we are taking for this path only, na? Organization to usefulness.
Oh, yes, sir.
So this has the chi-square and degrees of freedom value of this 11.843 and 5. We are checking for each of the three paths separately now.
Individuals.
Yes. Whether the moderation effect is there for all the paths. Moderation effect is there for the complete model. But it may be there that out of the 3 x's, all may not have a moderation effect. That's what exactly we are checking for each of the parts separately. So this is for the first one. This org to usefulness. So for this, our values are this 11.843 and 5. So that is what? So chi-square by degrees of difference of chi-square by difference of degrees of freedom is this value. And the p-value is this, which means it is significant.
So the there's a difference.
Yeah, the chi-square is tested for difference of chi-square versus divided by difference of degrees of freedom. This is the chi-square value. So that's what it is. Na? The difference in chi-square is this. And difference in degrees of freedom is this. So difference in chi-square by difference in degrees of freedom is this.
Okay, sir.
P-value corresponding to that is this. That means it is significant. That means nullity is rejected. So since it is rejected and it is significant, that means for this path, moderation effect is there.
Okay, sir. Okay, sir.
Now let us check for the other two. So how do you do that? You go to the second one, put the W in the second path, constrain it, and run the analysis and check for the chi-square I degrees of freedom, which is 5.657 and 5. Come to the chi-square test. Now it is not significant. For this path, it is not significant. That is for II to usefulness, the moderation effect is not there, because chi-square test is coming as not significant. Clear? Then you go for the third one. That is third path. So we put the constant for this TF to usefulness. In this third part, we have put the constant and the analysis. Look at the output. Chi-square by degrees of freedom, what is the value? 6.182 and 5. 6.182 and 5. Chi-square by degrees of freedom, difference in chi-square by degrees of freedom is this. P-value is again not significant. So the moderation effect is present in this model. The two groups differ as far as the model is concerned, but out of all the three paths which are significant, only the organization of information ORG to usefulness, this path is having a significant moderation effect. That means the two groups different for this path only. The other two graphs, as we have checked from the chi-square test, they are not significant. They are not significant. So what is the conclusion? That means the moderation effect is present in this model. That means in this case, the two groups differ, the males and females differ. As per the model is concerned, moderation effect is present. But if when you check individually for all the three paths which are significant, only for the path from organization information to usefulness, the moderation effect is there. Clear? So how to put that? How to report the result? First part is this: report the results of the comparison of the constant and unconstant model and then regression estimate. I'll come to the second part. The first part that we have discussed is results is this. So we have checked for the three paths separately, but out of the three paths, the moderation effect is only in the path from ORG to usefulness. It is present only from ORG to usefulness. Is this clear? Or is there any confusion here? Let me know. Any doubt?
No, sir.
So when we are presenting the results, statistical results, is it like which is more appropriate? Should write in sentence or should we can present in this way of table?
No, you can present in this way, then you have to explain in sentences. No.
Yes.
So how will I show you? The table should be there as well as this should be also there. See, here we have said we have taken for different, I have only taken the gender part. The gender part, the two models, unconstant and non-constant model, for the whole model, I am saying, it is significant. That's what we are saying in this here. After that, we have checked for individual paths, and with this table, we can say in case of gender, since the p-value in the given table corresponding to only this path was significant, that we can say gender moderate the relationship between organization of information and usefulness. For the other two, it is not significant. So you have to put the table and explain it in the words. So once you have done that, is this clear?
Yes, Professor.
Second part comes. So for the same path, you have to check which one has a higher effect. So you need to look at the standardized or unstandardized coefficient for the both groups. Now, what do you look at it? For the second part, you have to compare. See, moderation effect is present means the two groups are different with respect to this part. The two groups behave differently for this. Now, how is the behavior different? How to check for it? Go to the results, output, and look at the estimates for the path. See, the estimate for the female standardized 0.496 and standardized is 0.525. Generally, we look at the standardized to compare. Or for the male, it is 0.239. Exactly same what we have reported here. This is the second part of the table, which compares how are the two groups behaving. The estimate for the female is this and for male is this. So females have a higher estimate. That means how do you write it? That is the direction of moderation. That is what called as direction of moderation, whether the females are more or more less. So we look at this, and the writing is this: regression estimate of the path between this organization information is still higher for female end users more than the male end users, and it suggests that the female end users prefer to have organized information in the internet banking interface than male end users to derive more utility from the interface. So you have to write it in words like this. So this is also important to put this.
Sir, can you send me the papers? Send the papers, sir, for future.
I will
reference?
send you. I will send you later.
Okay.
At least not the paper. At least this part of interpretation I will send you, because the paper is not mine actually. I have taken another paper. So I'll send you at least the part of the interpretation that you interpret this.
Okay, sir. Thank you, sir.
Yeah. When I send you later this particular, I send you a refresher mail. I will send. In that I will send you. Just like the previous workshops. Those who are there in the previous workshop knows that part. So moderation is done in several steps. How do you do moderation? First, what do? We compare, look at the models. In the sense, we look at all the paths for the model and see which ones are significant for both the groups. So those paths which are significant for at least one group are retained in the model, and the paths which are not significant for both groups is first removed. One by one, not all together. We have shown you together like this, but what I have done is one by one I have removed. First I have removed this path, second I have removed this path. So once you have done that, and you stop at the point where all the paths are significant for at least one group, which we have stopped here. So once you have done that, then what you do, you compare the two models. One is a constant model, which is the left hand side, and then put a constant for all the thoughts and you get a constant model. And then you run these both models. Once you run the models, check for chi-square test or do a chi-square test for the difference in chi-square for the two models divided by difference in degrees of freedom. If the chi-square test comes out significant, that means there is a moderation effect present in this model. That means the two groups, male and female, which we have taken for this, that is there for this model. And once you have done that, then the moderation effect is checked, then you go forward and go for testing each of the individual paths one by one. So to do that, what you do, you put a constant for one path at a time and run the model. And in similarly before, you test for the chi-square difference versus degrees of freedom difference for both the models. Once it is significant, that means that the moderation effect is significant for that path. In our model, only this path from ORG to usefulness, that path was significant. The other two, II to or usefulness and TF to usefulness, the paths were not significant. That means the chi-square test was not significant. That means moderation effect was not present for these two paths. Moderation effect was only present for organizational information to usefulness. So that results you have to present first for all the paths which are there, which one has the moderation effect, which one does not have. Once you have done that, then for the paths which are significant and where moderation effect is present, you check for the regression coefficient between the two groups, in this case, females and males. The higher one is female in this case. That means female has, as a group, has more impact of organization of information to usefulness. That is what the interpretation is of the moderation effect. That females have a higher organization of information effect on usefulness. That is how you put the results or explain the results for moderation through. So this is called as a multi-group analysis. Why it is called a multi-group analysis? Because when you are defining the model, when you are defining or putting the data set in the model, what you do is you need to define it in this way. That means your groups has to be defined separately from your data set. And that's why it is called as multi-group analysis also. In this case, we are divided into male and female. In fact, the data set that I have sent you, there are a number of categorical variables. There is this male, female, then there is this age group, and then there is a low user, high user, some 3-4 variables are there. So we have done it for gender, but for the others also you can check. So there is this age group, then education level, etc. Number of categories are there. So you can check for each of them for your model, for the moderation effect of each of them. You can check for that. And once you have done that, you need to report for individual paths, which one has a moderation effect. And in the paths where moderation effect is there, how are the two groups differ from each other. That's how you check. If you have more than two groups, then also you can have a moderation effect. Then also you can look at the chi-square for degrees of freedom for each of the paths between the two groups, between the three groups, and similarly also regression coefficients. I think Mr. Umakant has sent the feedback link, so you can put the feedback whenever you get time during the workshop. Feedback link is there, has been shared in the chat box. So you can put the feedback there. So it is only for two groups I have shown you, but it can be done for multi groups also in a similar way. Between male and female, you have 2-3 age groups or 2-3 education level, you can check for that. Okay. So This is exactly where I will stop my part. You have any doubts or any questions regarding this, you can ask me.
Sir, I have one doubt, sir.
Yeah, tell me.
P-value, for which model we should see the P-value, sir, for the constant model?
Now, first, when you are checking for the moderation of the model, whether the moderation is present in the model, then you compare unconstant and a fully constant model. The square and degrees of freedom for those two models. Clear?
Sir,
Thing that you need to check.
no, sir, for P-value, you are writing the P-value.
P-value is
sir.
for the difference of square versus difference of degrees divided by degrees of freedom. This
That value should be taken as a P-value.
is the P-value.
Okay, by dividing it, it is a P-value. Okay, sir.
No, not
Understood.
dividing it. It is the
Ah.
chi-square test for the P-value that we are talking of.
Yes, sir, I'm asking about the P-value, sir. From where
Value
we
will
should
come, put the square test of difference in square divided by
Ah.
differences of degrees of freedom. So the value has come because I have conducted a square test for this.
that in the text output, right? So in the output box, the P-value is shown.
This P-value, na, you are showing. This P-value you are asking?
I can't see the screen, sir.
Okay, okay. 1 second. Which one? This P-value you are asking?
Yes, sir, exactly the P-value. So,
That is for the square test divided by degrees of freedom. So once you put
Okay.
formula, it will automatically calculate the P-value. I have done a
Okay.
square test.
Okay, sir. Okay, sir, understood.
So first you check for the model, and then for each of the parts you check separately.
Okay, sir. Okay, sir. Yeah, got it.
First for the model, if the model is have a moderation effect, for each of the individual parts you need to check separately.
Oh, okay, sir. Got it. Okay, sir.
Yeah. Anything else? Anybody else?
Sir, here the moderator is a categorical variable. What if it is a scale variable?
Moderator is generally always a categorical variable only, where you are talking about multi-group analysis.
Suppose if it is a scale variable, we can't
No,
do
scale
a
variable cannot be a moderator. No?
Okay.
Moderator is what? How are the two groups differing?
Okay.
That is
Okay, sir.
relationship between two variables, X and Y, how it is affected or how it is different between two groups, two or more groups.
Okay.
That's what is the moderator, na? It's always a categorical variable.
Okay, sir.
Scale variable is not a moderator, that will be a mediator.
Okay, sir.
Yeah. Anything else? Anybody else?
So if I want to check a scale variable, I can like convert into a category, so like low, medium, and high, and can I check like that?
So you can do if it is a scale variable and you want to use it as a moderator, you have to convert it. Na?
Convert into
Like,
low,
for
medium, or
example,
high into
any
a category.
continuous variable like age. Age is a continuous variable. It is not a categorical variable, no?
Yes,
So
sir.
you can have a moderation effect of the age. How do you do that? You convert it into low and high. Just like what we have done in this paper, it has been done age, low and high.
Okay.
I have
Okay.
converted into two categories, high and low.
Okay, sir.
Okay.
Okay, sir. Thank you, sir.
In this paper or in this data set, if you look at, it is
Sir,
there.
can't see the screen, sir.
No, the paper that I have shown you, and the data set that it is there.
Okay.
Data set, it is there. You can see age group and all those are there. There are 3-4 categorical variables. So age group is a continuous variable. Age is a continuous variable. Na? So to run a moderation with the age group, I have divided it into two. One is low, one is high. Under 30, above 30. And run it as a moderator. In the data set where I have sent you, there it is there. You can see age. There is 2 parts.
Okay, sir. Okay,
Yeah.
thank you.
Anything else? Anybody else?
No, sir, I don't have
Anything on mediation? Anything on moderation? Both.
As of now, it is clear.
Okay. So if you have any doubts also later, you can ask me. You can email me if you have any doubts or anything anywhere when you are actually doing it. With the
Yes,
data
sir.
set I have sent you, there are a number of categorical variables. You can use them as moderators and check for them.
Okay, sir. Thank you so much.
Yeah. Okay. So if there is nothing else, we can stop here. Just a reminder from Mr. Umakant again. You need to put that feedback form, which is there in the chat box.
Okay, sir.
So if there is no other doubt, we can close there. Close the session here.
Okay, so thank you so much,
Thank you so
Professor.
much, sir. Thank you.
Yeah.
Thank you, sir.
Yes. So thanks for attending the workshop. So for this year, my series of workshops or FDPs are over. I have done 5 for different topics and subjects. So I'll repeat it again next year. Maybe some of your colleagues or anything who will be there next year can join. Fine.
Thank you, sir. It was very useful for us.
Yeah.
Thank you so much, sir.
It will be more useful if you can apply it.
Absolutely.
Yes. And then you get any confusion and doubts while applying it, you can contact me.
Oh, that's great, sir. Thank you so much.
Yeah, sure, sir.
Thank you, sir. Sure, sir.
Sure. Bye. Goodbye.
Bye, sir.
Yeah.